Okay, today is June 6th. June 6th, 2011. We're going to be taking up Chapter 1's test. Unfortunately, I couldn't get the test up on here. It's taking too long. So, what's going to happen is I'm going to give you the question. And excuse me. We're going to go through it together. So the first question said to solve by graphing these two linear expressions, 3x minus 2y equals negative 8, and x minus 2y equals negative 4. Okay? There is a graph on your test, so I'm going to put a quick graph up here right now. Yes, you can print these. So the XY graph. Doesn't matter, I don't need to stop things. I don't know, they just gave me unlimited time. Okay, so there we go. 2, 4, 6, 8, 10. Make your graph while I'm doing this. Hopefully, the point of intersection between these is going to fall on this graph. Okay. So we've labeled our graph. Now we need to graph these two linear equations and figure out their point of intersection by graphing them. Now, in order to graph them, you need to put them into y equals mx plus b form. Okay? In other words, it needs to look like y equals mx plus b, m being our slope, b being our y-intercept. Now, right now, both of these equations are not set equal to y. So I'm going to take the first equation, we'll do it in blue, 3x minus 2y minus 8. 3x minus 2y equals negative 8. I'm going to set it equal to y. So I'm going to bring the 3x to the other side of the equation. And this is going to become negative 8 minus 3x. I need to isolate for y, so I'm going to divide both sides of the equation by negative 2. So that's everything on this side. This side becomes y equals 4 plus 3 over 2x. Okay? And your y equals mx plus b, this is it. Our slope, if you guys want me to write it just reverse, it's 3 over 2x plus 4. Both still the same equation. Our slope is 3 over 2, and our y-intercept is positive 4. So, I'm going to go up to positive 4. I know my rise is 3, 1, 2, 3, and my run is positive 2, 1, 2. I can go up 1, 2, 3 again, 1, 2. Or I can do the complete opposite. Instead of rising positive 3, I go down 3, 1, 2, 3, and run negative 2, 1, 2. Still on the same line. So I'm going to continue this line. Draw a straight line here through these points. We have something that looks like that, we're going to say. Okay? So that's the equation of our first line. Our second line we'll do in red. X minus 2y equals negative 4. X minus 2y equals negative 4. Exact same idea. I need to isolate for y. So I bring the x to the other side. It becomes negative x. And I divide both sides by negative 2. This will become y is equal to 2 plus, now this looks like x over 2, but it can also be written as 1 over 2x, a half. You guys are used to seeing the slope first, so I'm just going to quickly rearrange it for you, but it really doesn't matter. If you can read it from the other equation, that this is our y-intercept and this is our slope, Still, this is our slope, this is our y-intercept, made no difference. So our y-intercept is positive 2, and our slope is 1 over 2. Positive 2, up 1 over 2. Up 1 over 2. It looks like if I go this way, I'm not going to intersect the line. But if I go the opposite way, I will. So let's draw a straight line through these points. I'm having a bit of trouble there. Let's see, it's about there. So just to verify, I'm going to go from this point down 1, back 2, and this would definitely be a point. So we found it as a point on both lines. So through intersection, we discovered that these two lines intersect at -2 and +1. That is this point here. -2 and +1. That is where these two linear equations intersect each other. That was question 1. Question 2 on your test says find the point of intersection, but it doesn't give you a specific way of solving it. So it gives you these two lines, 4x minus 3y equals -1, and 20x minus 12y equals 5. So it says to find the point of intersection. I could graph, I can substitute, or I can eliminate. A show of hands, how would you like me to solve this? There's eliminate, substitution, and graph. So who wants me to graph this? Good. Who wants me to eliminate this? And who would like me to substitute? They'd vote. Eliminate. All right. We're going to solve by elimination. Okay? So to solve by elimination, what I need to do is I need to match up one of the coefficients. I need to make them the same number. So if we take a look at the coefficients here, since I always like adding, I'm going to turn our first equation. I want to have a -12 in front of our y. So I want a -12 as a coefficient. So in other words, I'm going to need to multiply the entire first equation by what? Anyone know? 4. By 4. That's right. When I multiply it by 4, I end up with 16x minus 12y equals -4. My other equation stays the exact same. I have 20x minus 12y equals 5. And because we're solving by elimination, to eliminate the -12 and the -12, I would add these together. I could always subtract them, but subtracting them won't eliminate those two. So when I add 16x plus 20x, I get 36x. -12 plus -12. Oh, that's -24. Sorry, we don't want to add. We want to subtract. My fault. Big mistake. No, at least we figured out our mistake. We want to subtract these. So that -12, subtract -12. These two negatives become a positive, so it says -12 plus 12. Okay? In other words, that means this is going to change. 16 minus 20 is -4x. -12 subtract -12 is 0. And -4 subtract 5 is -9. Okay? I'm just going to bring these closer together. I need to isolate for x. So I divide both sides by 4. It becomes -9 over -4. Thank goodness I didn't graph this. Okay. Now I can solve the other one by elimination also. Let's write our two equations again. 4x minus 3y equals -1. 20x minus 12y equals 5. Okay. This time, I forgot the x. This time I'm going to try to eliminate the x. So that means I need the coefficients in front of the x to be the same. So again, I'm going to multiply the first equation. I'm going to create a 20. So I need to multiply the entire first equation by 5. So I'll get 20x minus 15y equals -5. Second equation says 20x minus 12y equals 5. And in order to eliminate the 20s, I need to subtract them. So 20 subtract 20 is 0. Negative 15 subtract negative 12. Anyone know? Close. Negative 3y. Write that up here. Negative 15 subtract negative 12. Ends up being 15 plus 12. Negative 3. And negative 5 subtract 5. Negative 10. Good. I got to isolate y, so I bring this 3 over to the other side. I get negative 10 over negative 3, also known as 10 over 3. So, my two answers, y is equal to 10 over 3, and x is equal to, oh, I forgot to rewrite that one also, 9 over 4. Now, if you wanted to write this as a decimal so that it makes sense to you in case you needed to plot it, this answer here is 2.25. That's our x. And our y is 3.3 repeated. That is our y as a decimal. Okay? If you wrote it in decimal form or fraction form, both are fine. It didn't say you had to do one or the other. No, it's negative 10 divided by negative 3, and because they're both negatives, they become positive. Question 3. Okay, question 3 says, if a linear system has one solution, so one solution, what do you know about the slopes of the two lines? Okay, in order to answer this question, I'm actually going to talk about the others. The other options are to have no solutions, or infinite. So I'm not great at spelling. I'm going to try infinite. ITE is it? Solution. Okay, great in English. I didn't do well in spelling. I was just going to put that sign. Okay. So, Daniel? Yes, exactly. So, if you have no solutions, what that means is you have two parallel lines, okay? So here's one line. I'm going to try that as best I can. There's another, okay? That means they're exactly parallel, which means they'll never touch each other, so you have no solutions to that. An infinite amount of solutions, I want you guys to watch carefully. We have one line, and I'll do the second one in blue, just so you can get an idea. Infinite amount of solutions would be two lines that have the exact same slope, exact same intercept. In fact, they have the exact same equation. Okay? So infinite amount of solutions have are the same equation. So same equation. No solutions are parallel. And one solution is, anyone know? So we're going to actually solve for one solution now. What does that mean? They're just different. They're not parallel, and they're not the same equation. They could be perpendicular. They could have slopes that are reciprocal. They could have so many different things. Okay? So instead of describing all of those, I'm going to describe the two things they're not. They are not parallel. I spelled parallel wrong up there. And they are not the same equation. So in other words, there are two lines, and this is just an example that look like this. They cross each other at one point. Okay? Do you guys have questions about that one? Move in. Question 4. Question 4 says to solve by substitution, so we're going to substitute. And your two equations are 2x plus y equals 2. 3x plus 2y equals 5. Okay, so solve by substitution. Okay? To solve by substitution means I need to take one equation and set it equal to one of the variables. So I'm going to take the first equation, I'm going to do it in blue. We'll call this equation 1. I'm going to set this equation equal to y. It's really easy. I just got to move the 2x to the other side. So y is equal to 2, subtract 2x. Now that I have that, I'm going to substitute this in for y of the other equation. So the other equation we can do in red. So our equation 2, 3x plus 2y equals 5. So what I'm going to do now is I'm now going to replace the y in this question with those values. So 3x plus 2. And then instead of writing y, I'm going to write 2 subtract 2x equals 5. Okay? So now that I've substituted this, I'm going to write the rest in black now. Now that I've substituted this, I have 3x plus 2 multiplied by 2 subtract 2x equals 5. I'm going to distribute in the brackets. So I get positive 4 and negative 4x. I'm going to combine my like terms. So I have 3x and minus 4x. What am I going to get? Negative x plus 4 equals 5. I'm going to bring the 4 to the other side. So it becomes 5 subtract 4. Negative x is equal to 1. But I'm not looking for negative x. What am I looking for? Yes. So what do I have to do to this x? Divide by negative 1 times negative 1. I just got to make it a positive x. So what is the 1 going to become? Negative. So I now have x is negative 1. Now with that information, I can plug that into either equation 1 or equation 2 to solve for the y. Which one would you guys like me to do it into? 2? Okay. Equation 2. 3x plus 2y equals 5. We're going to substitute this negative 1 in for the x. So I get 3 times negative 1 plus 2y equals 5. Negative 3 plus 2y equals 5. I bring the negative 3 to the other side. Becomes 5 plus 3. 2y equals 8. I divide both sides by 2. Y equals 4. So my answers are x is negative 1, y equals 4. That's solving by substitution. Question number 5 on this. Question 6. Solve the following system by elimination. Lucky for you guys, you've already done an elimination question. Okay, so once again, by elimination, I need my coefficients to be the same. And if you guys notice, my coefficients for the x and the coefficient for y, they're not factors of each other. So I'm actually going to have to multiply both equations in order to make them have the same coefficient. So first off, let's just say I want to get rid of the x's. Well, I have a 3 and a 5. To get a common coefficient, I can use 15. That means I'll multiply the first equation by 5 and the second equation by 3. That'll give me 15x plus 10y equals 170. And then 15x minus 9y equals negative 39. I need to eliminate. I'm trying to eliminate my x's. They're both positive 15, so I'm going to subtract these two equations. That will cancel out both the x's, so there would be 0. 10 subtract 9 is 19y. 170 subtract negative 39 is going to be 209. I need to divide 209 by 19 in order to solve for y. So 209 divided by 19 equals 11. Hey, that's nice. So y is equal to 11. That was pretty simple. Now the same idea, I'll rewrite the question actually, just so we can see what I'm doing. Same numbers. 3x plus 2y equals 34. 5x minus 3y equals negative 13. This time I want to eliminate, this time I want to eliminate my y's. So again, I need a coefficient that is similar between the two of them. So because I have 2 and 3, I know that 6 is a common factor. So I'm going to multiply the first equation by 3 to turn this coefficient into a 6. And I'm going to multiply this equation by 2 to turn that coefficient into a 6. So I end up with 9x plus 6y equals 102. Is that right? Yeah. And 10x minus 6y is equal to negative 26. Now, here I have plus 6 and negative 6. So I'm going to add the two equations to eliminate the y's. When I get 6 plus negative 6, these two will cancel out. I'm going to have 19x is equal to 76. Let's make sure. 102 minus 26. Yeah, so it's 76. Okay, let's just write these so they're closer to each other. 19x equals 76. I need to isolate for x. Divide 19. Oh, thank you. 76 divided 19. 76 divided by 19 equals 4. Yeah, it worked out really nice. What a nice teacher you guys have. So, y was 11 and x was 4. Solved by elimination. Ready? Okay, question number 7. We won't get to 8. X divided by 2 plus y divided by 8 equals 4. X divided by 3 minus y divided by 2 equals negative 2. So when you guys look at this, you see a relatively complicated question. Okay? What I'm going to tell you guys is this is actually quite easy. Think of the same types of stuff we're doing with elimination. I want to get rid of all of my fractions. I want to get rid of all these denominators at the bottom. So I'm going to use a common factor, and I'm going to multiply the first equation by a common factor of the first two denominators. And I'm going to multiply the second equation by a common factor of the next two denominators to eliminate them all. So what I'm saying is the first equation, a common factor of 2 and 8, does anyone know? 8. So I'm going to multiply this entire equation by 8. I'll show you what that looks like. Yes. Okay, so like I was saying, there's many ways you guys could have done this. Some of you would have got a common denominator. The fastest way, personally, I think, is to do it like this. So I'm going to multiply each term by 8. So I get 8x over 2 plus 8y over 8 equals 32. I can now simplify both of my fractions. 8x over 2 is the equivalent of 4x. 8y over 8 is the equivalent of 1. And I have 32. 4x plus 1 equals 32. That is my new equation without any fractions. I did forget my y. Multiples. You're right, I was using the wrong term. Sorry, I meant to say multiples of these numbers, not factors. Okay, second equation. Same idea. I'm going to find multiples. I was using the wrong term. of 3 times 2, or 3 and 2. So a multiple of 3 and 2 is 6. So I'm going to multiply the entire first equation by 6. So that will give me 6x divided by 3 minus 6y divided by 2 equals negative 12. I can then simplify the fractions. I get 2x minus 3y equals 12. And again, I have my second equation without any factors. Go on here. I'm not done. So, I made 2 equations. I haven't actually solved for any point of intersection. Okay? So I've made 2 equations that are now easier to work with. So I have my 2 equations. I have 4x plus y equals 32. And I have 2x minus 3y equals negative 12. I now have 2 equations that are much easier to work with. I don't have any fractions, so equation 1 and equation 2. Now I could do substitution, I could graph these, or I could eliminate. I've already done 2 by elimination, so let's do this by substitution now. Okay? So by substitution, I'm going to take my first equation, set it equal to y. Oh, I meant to write it in blue. 4x plus y equals 32. Bring the 4x over, done. Y is equal to 32 minus 4x. I'm going to plug that into my second equation, 2x minus 3y equals negative 12. I'm going to substitute this new bracket, 32 minus 4x, for the y in the other bracket. So what that will look like is 2x minus 3 times 32 minus 4x equals negative 12. And we'll write that in black in the middle now, so it's a little easier to deal with. So what that says is 2x minus 3 times 32 minus 4x equals negative 12. We're going to distribute the 3, so I get 96, and then plus 12x equals negative 12. I'm going to combine my like terms, so I'll get 14x minus 96 equals negative 12. When I bring 96 to the other side, it becomes positive. 14x is equal to 84. When I bring 14 to the other side, I divide it. X is equal to 84 divided by 14, 6. So, all I did was solve for x, though. Still not done. A lot of work here. I'm going to substitute that into our original equation. 4x plus y equals 32. And what I mean by original is our first equation. Our first equation said 4x plus y equals 32. If x is 6, I'm going to substitute it in there. So I have 4 times 6 plus y equals 32. 4 times 6 is 24 plus y equals 32. And when I bring 24 to the other side, it becomes negative. Y is equal to 8. So x is 6 and y is 8. A very, very long question. Took a lot of work to solve that one. All right, gentlemen, so your review questions for the rest of year. Page 438 to page 447. Find any space in your blue notebook to write it. I realize I did not give you a whole bunch of pages at the end. So use any space in your blue notebook. There's almost 10 pages of work. That's the entire course review. Do them all. That way you're a genius.